So nice meeting everybody. I'm Tim, work at Akamai as my day job as a performance specialist. And in the evening, I also work on the largest and fastest scale modeling website in the world. And UNO is something an idea I came up with not that long ago. And I want to share this missing link in your time to first byte analysis. And typically when I hear UNO, some people think about this. So UNO helps when two countries are fighting. The other UNO is when my two kids are fighting, I take this game and everybody is happy and we dissolve everything. Now, when it comes to time to first byte analysis, sometimes the discussions can be quite heated and this UNO is actually helping with that. So what does UNO stand for? UNO stands for unattributed navigation overhead. Or you take time to first byte, you deduct everything you know, and what is left is called UNO. Now, why is that needed? Because if you take from the start till the end, we know time to first byte contains redirect, DNS lookup, TCP, TLS, waiting time, service worker startup. All those things are part of time to first byte. But this view is a little bit fantasy, because if you really look closely at all your run data, you will actually see that between these individual measurable steps, attributable steps, there are little gaps. And these little gaps, when you combine them all together, that's what basically UNO is. Now, the question is, how big is this? Is this oh, Tim, you're trying to shave off microseconds from a website? Or can this actually be several seconds big? And it can actually be several seconds big. But let's first look at my own data just to get started. So this is based on Ample's real user monitoring. So all the data on my website is tracked, and I track unattributed navigation overhead. And at the P10, so the fastest 10%, it's only 2 milliseconds. Let's agree this value can be ignored. It's likely some rounding errors, nobody cares. At the P75, 20 milliseconds, let's agree that it's still not really that big. But if you're looking at the higher percentiles, it quickly gets above 100 milliseconds. Now, if you know that my P75 is 500 milliseconds, the percentage error can actually be fine. Now, that's one example. Now, during my day job at Akamai, I also work with some of the larger brands around the world. And sometimes I get some escalations on my plate saying, hey, Tim, time to first byte is bad. Let's fix it. And this is one of my customers. This is now, in the meantime, 2 years ago. Their time to first byte at the P75 was 1.4 seconds, which is high. And especially if you look at the poor value, almost 20% of them, it took more than 1.8 seconds, which, let's agree, if you're on a CDN, is not the expected value you want to get. Now, when I came in, it was like we had some brutal meetings, and I exaggerate now a little bit, but people were saying, hey, it's the CDN. The CDN team said, no, it's the backend. The backend team said it's the front end. Somebody said it's the DNS database team. So they spent months and months and months trying to improve that 1.4 seconds. And after months and months and months, maybe 50 milliseconds were improved, not the real issue. At some point in time, it came on my plate. And I said, hey, this smells like UNO. So we looked at this customer, P10, 8 milliseconds, agree, we don't care that much about it. P75, already 400 milliseconds. Now, if you can improve if you know that this is part of time to first byte, and time to first byte impacts LCP, if there is 400 milliseconds, you don't know what's going on. If you can remove that, your LCP will be a lot better. Now, if you look at the P98 and the P99, it was 4 seconds, 5 seconds, 6 seconds, added on top of all the other things they did. And of course, if you remove 1 millisecond from the database or make the CDN 2 milliseconds faster, if you add 6 seconds, then you have an issue. Now, short story, what was the issue? I will straight away go in there. And typically it's either DNS or it's ads. And in this case, it's ads. If some, like everybody else, they did advertising on newspapers, and when somebody clicked on the banner, you see this typical redirect pattern. And in this case, it adds 1,222 milliseconds. Now, in our world, when we discuss, this is a redirect. Redirects are captured in RUM. Redirects are visible in the browser. You can even see even test this in a synthetic way. But what is the problem? The problem is these redirects are not counted as are not attributed to redirects. And why is that? There is also certain things like security and privacy on the web. And because these redirects come from a third party, they're basically not attributed to the redirect timing. So if you look at RUM, the redirect would actually be 0 in those cases. And 1.2 seconds is part of time to first byte, but it's part of the attributed thing. So if you would just look at what they did before, is they looked at their, oh, do we have a redirect issue? RUM would say, no, everything is fine. Do we have a TCP issue? No, everything, all numbers looked fine, but the total number was a lot bigger. Next thing we did is we then looked at the UTM campaign parameter. So that told this customer from where the traffic came. And they had different sources, like some publishers using Google AdSense, for example. That's like the lower one. But you have other tools to attract traffic, let's say Taboola or other widgets on other websites to attract things. And what we noted there is that for certain of these traffic sources, the UNO value was 2.5 to 5 seconds. Because they had so many redirects or so slow redirects or the combination of both. So based on this data, what did we do? Or what did they do? Is they first, because they now had visibility into UNO, they could understand the problem. They turned off one of their slowest providers just to validate things. And we also had chats with some of the ad providers to actually make their redirects a little bit faster. For example, increase the NSTTL, making sure that they use TLS 1.3 instead of TLS 1.2, all reducing the UNO kind of thing. And of course, if here in this case, 10% or 11% less or fewer users having a poor experience, this also contributed to their LCP. And for the first time in months, they're actually able to see LCP improvements. And that was good news because everybody was blaming Akamai. Akamai was saying, no, it's not us. And yeah, it was escalating, and UNO basically solved the mystery. Now, let's look a little bit closer at some of the other values. So this is back to ScaleMate's data on the lower end, but just to show you the impact. So if you're looking at landing page true or false, so landing page is the first page in a session. There you see that unattributed navigation overhead is bigger than when it's false. Now, why is that? I don't run any ads to attract traffic. So why do I still have these higher values? I assume, I can't be sure because it remains something unattributed, but I assume it is because of many URL link shorteners which exist on the web. So when people reference my website or somebody posts a link on the forum, rather than going directly to my site, often many of them use like tiny URL, or the internal forum software will do some redirects to measure how many links, how many clicks that link got. All those redirects are part of time to first byte, are not captured, and are therefore likely part of the unattributed navigation overhead. And why false? Yeah, that can be plenty of other reasons. Other thing is interesting to see is if you look at the run data by device memory, you will see that faster devices also have smaller unattributed navigation overhead. So that's I would say almost as expected, but it does even for my website, which is quite fast, it does get into the 200 milliseconds range on slower devices. And visibility state. So visibility state always visible means that it's your tab or your page loads on the tab the persons are looking at. Always hidden or partially hidden means that it's like an invisible tab or people switched. Then you will also see that the unattributed navigation overhead is a little bit bigger. So those are some interesting facts around that. And the other thing, which is, I think, key to know, is DNS is DNS. If you're looking at 700 different RUM tools, every DNS lookup should be an exact DNS lookup. Now, UNO is RUM specific. What do I mean with that? Is it depends on what the RUM tool actually measures. For example, amples, we capture all these things. So in that case, UNO is the sum of all the gaps. Suppose your RUM tool would not capture service worker startup times, and you have a service worker in place, then the overhead of the service worker startup would not be captured and therefore would be part of your UNO number. And then what is the most popular RUM tool in the world? Crux. Now, what is the UNO value in Crux? If you look at Crux, you only see time to first byte. You don't know what a DNS lookup was. You don't know what TCP was. So so there is no attributable component of time to first byte, meaning that for Crux, UNO equals time to first byte. Like if your time to first byte goes up, you have like no way to understand what the reason was. Now, I didn't mean to be like, I'm not unhappy with Crux. I just want to show you that UNO really depends on the website. So with that said, next time when you are in a fight with either your colleagues or with your customers or with your vendors or whatever, because you see strange things, think about what I said. Don't start fighting, just think about UNO. And that will basically solve your life, make your life easier, and reduce the time you need to actually find issues, and also avoid you wasting time on removing here and there 1 millisecond while the actual problem is maybe 2 seconds, 3 seconds big. With that said, I'm at the end of what I wanted to say. Are there any questions?